This is not supposed to exist. It's not a simulation. It's not concept art. It's real light, captured by a real mirror, coming from a place physics still can't explain. It traveled for 13.5 billion years just to reach this exact moment on your screen. And when scientists finally understood what they were looking at, they didn't use the word discovery. They used the word miracle. Not because it's beautiful, because they had no other word for something that, according to everything we know about how the universe is born and grows, simply shouldn't have happened this early. In the next few minutes, you're going to watch the most expensive telescope ever built find, one after another, things that should be impossible under the very model we use to describe the creation of everything. You're going to see adult galaxies where there should only be dust. You're going to see a black hole grow too fast for the time it had. And by the end, you're going to understand why one of the most serious explanations, proposed by physicists, not YouTubers, is that maybe we don't even understand what kind of universe we were born into. What you're about to see changes the way you look at time itself. Before I show you what broke, you need to feel how solid this rule seemed. The universe is about 13.8 billion years old. For the first few 100 million of those years, there were no stars, no galaxies, no light of its own, just a dense, hot, silent soup, hydrogen and helium floating in the dark. Astronomers call this period the cosmic dark ages, and slowly, gravity did its work. Gas clouds collapsed, the first stars ignited, and from them, the first galaxies began to form, small, clumsy, still figuring themselves out, like a child learning to stand. That growth, according to the model that supports nearly all of modern cosmology, takes time. Billions of years of mergers, collisions, slow accumulation of mass. A galaxy the size of the Milky Way, with the mass and maturity ours has today, simply should not exist when the universe was only 2% of its current age. That wasn't an opinion. It was a mathematical prediction built on decades of observation. And that's exactly the prediction the most advanced telescope ever launched into space was built to test. It just had to look deep enough. February 2023, the James Webb had just started operating. An international team, scanning the first deep images, found 6 points of red light dating between 500 and 700 million years after the beginning of everything. They were supposed to be faint smudges, cosmic infants still forming. But one of those points contained, roughly, as many stars as the Milky Way has today, compressed into a space 30 times smaller. The scientists who made the discovery couldn't find a dignified scientific way to describe it, so they reached for something else. They called them universe breakers. One of the researchers described the moment he first saw the data with the sentence that honestly doesn't sound like science. It sounds like someone getting the scare of their life. We were mind blown, kind of incredulous, and the most disturbing part wasn't that these galaxies were big, it was their color. A newborn galaxy full of young, hot stars should glow blue. These were glowing red, the color of stars that have already lived, already aged, already burned through much of their own fuel, like walking into a maternity ward and finding someone with white hair. And that was only the first sign, because over the next 2 years, Webb didn't stop finding things like this, each one a little more unsettling than the last. But everything you've seen so far is just the beginning, because what came next didn't just challenge how big galaxies could be, it challenged the very idea that we understand how anything in the universe begins to exist. In 2024, a team found JWST 7329, described by the researchers themselves as the most extreme example of its kind ever seen. An old, heavy, fully formed galaxy, existing at only a fraction of the time theory says is required for that to happen. The scientist who led the study didn't soften her words. She said having galaxies this massive, this early, was posing serious challenges to the standard model we use to describe the creation of the universe itself, not an adjustment, a challenge. And it didn't stop there. Months later, another team found 3 galaxies, nicknamed red monsters, nearly the size of the Milky Way, within the first billion years of the cosmos existing. They were converting gas into stars with an efficiency the models considered, until then, physically implausible. But what actually made the scientific community go quiet wasn't a galaxy. It was what was hiding inside one of them. There's a galaxy called GNZ11. It existed when the universe was only 400 million years old, about 3% of its current age. In January 2024, the James Webb confirmed that, at its center, something was feeding. A supermassive black hole, active, ravenous. For a black hole to reach that size through the process we know, growing slowly, swallowing matter bit by bit, it takes almost a billion years. The universe, at the time this black hole already existed at that size, hadn't even lived half that long. Think about that for a second. Stop for a second. Really think about what that means. It means something in the early universe fattened a black hole at a pace our own physics says shouldn't be possible. And there's a cruel detail in this story. As the black hole grows, it pushes out in an ultra-fast wind the very gas the galaxy around it would need to keep forming stars. In other words, the same thing that proves something is wrong about the timeline is also slowly choking the galaxy that produced it. The monster at the center might be killing the house it was born in. And the worst part is, GNZ11 isn't even the record anymore. Not even close. Remember the light you saw at the start of this video? It has a name, JWST 14-0. And for a while, It was the most distant thing human eyes had ever seen. Its light left its source 290 million years after the beginning of everything. If you compress the entire history of the universe into a single 12-month calendar, the Big Bang would be January 1st. This galaxy already existed on January 7th. Dinosaurs wouldn't show up until December 25th. Modern humans in the last 10 minutes of December 31st. And still, we built an instrument capable of looking all the way back to January 7th of the universe itself. But the record didn't last long. In April 2025, a team reanalyzing old Webb data noticed something strange, an object that appeared clearly in infrared but vanished completely at shorter wavelengths, a classic signature of something extremely distant. They pointed the telescope directly at it, used the spectrograph to dissect that light wavelength by wavelength. The result confirmed an even higher redshift. They called it MOM Z14, and it took the title. Its light left its source only 280 million years after the beginning of everything. It's tiny, about 400 times smaller than the Milky Way, but it's shining far, far brighter than a galaxy that size, at that age, should be capable of shining. And when they analyzed the chemical makeup of that light, they found something that made no sense at all. A ratio of nitrogen to carbon that, until then, we'd only seen in one thing: extremely old stellar clusters, structures that, according to everything we knew, take billions of years to form. That chemical signature showed up in a galaxy that, at the time, had existed for less than 300 million years. That rewrites the timeline for when this kind of structure could even begin to form in the universe. If that bothers you, drop a number in the comments. How old do you think the universe actually was when that light left its source? Because the official answer might not be the right one. Here's the moment this story turns inside out. For years, scientists assumed these compact red smudges, nicknamed little red dots, were old galaxies, too dense, too tightly packed to be anything else. But Webb could never resolve them into a recognizable galaxy shape. They were too small, less than 2% the diameter of the Milky Way, too compact to fit anything resembling a normal population of stars inside them. The problem was never the size, it was what, possibly, was inside them. A growing number of scientists now believe many of these little red dots aren't ordinary galaxies at all. They're supermassive black holes, wrapped in a dense cocoon of gas, feeding in bursts so violent they exceed the theoretical limits of how much a black hole should be able to eat at once. In later epochs of the universe, about 1 in every 10 galaxies shows signs of an active nucleus like this. In the younger universe, that proportion should drop to a fraction of a percent. Instead, among these red dots, the number reaches 3 to 4 out of every 100. A population explosion of monsters, exactly where physics said they should be rare, and after growing this violently, they vanish. Almost all of them before the universe turns 2 billion years old. A researcher who spent years trying to understand these objects once said in an interview that chasing this answer was the most fun she'd ever had in her career. But listening to the rest of that interview, it didn't sound like fun. It sounded like the specific excitement of finding something that shouldn't be there and not being able to look away. Now, here's the comfortable explanation. Part of the scientific community argues that maybe we simply measured wrong. A more recent instrument on Webb itself, sensitive to longer wavelengths, found that the mass of several of these impossible galaxies had been overestimated, in some cases by nearly 2.5 times. Maybe some of the dust in these galaxies is simply hotter than we assumed, glowing as if there were far more old stars there than actually exist. Maybe the ratio of small to large stars forming in the early universe is different from what we see in our own galaxy today, throwing off the math completely. That's real. That's science correcting itself the way it's supposed to. And for a moment, it feels like the ruler snaps back into place. Except there's a problem. A recent study trying to settle exactly this question went looking for the closest descendants of these impossible galaxies, later versions, easier to measure precisely, and it found the opposite of what it expected. Instead of confirming there were oversized stars being miscounted, the study found an excess of small stars, the kind that, ironically, makes these galaxies even harder to explain, not easier. Every attempt to fix the problem, so far, either closes one crack or opens 2 new ones. And that's exactly the point where a small, but serious, part of the scientific community raises a question most people prefer not to ask out loud. What if the problem isn't how we're measuring these galaxies? What if the problem is how we understand the very beginning of everything? Some physicists have seriously proposed alternative models of gravity, versions of physics where gravitational pull in the early universe was stronger than we assume, letting matter collapse into galaxies far faster. Others argue that primordial black holes, formed in the very first instance after the beginning, before even the first star, may have acted as instant seeds, letting entire galaxies organize around them almost immediately, skipping steps we thought were mandatory. And there's an even more uncomfortable hypothesis, held by a small number of physicists, rejected by most, but that no one has been able to rule out completely. The idea that what we call the Big Bang wasn't an explosion from nothing, that it was the moment dormant matter collapsed to form a black hole inside a larger, older universe that we may never be able to observe, and that our own universe, everything you've ever seen, everything you are, might exist inside an event horizon. Nobody is saying this is true, but nobody so far has been able to prove with absolute certainty that it isn't. Remember the word scientists used at the start of this video? Miracle. Now you know what was behind it. It wasn't just admiration, it was the sound of highly qualified people staring at light 13 billion years old, realizing two things at the same time: that it was real and that it shouldn't be possible. If you made it this far, you're probably feeling something strange right now. Not quite fear, not quite calm curiosity either. That's not you overreacting. That's your brain trying to process an idea it was never built to handle. That the map of time you learned to trust, the map that tells you where you came from and how long any of this has existed, might be incomplete in a way no one knows how to measure yet. But James Webb keeps looking, and the deeper it looks, the more of these impossible galaxies keep showing up. The distance record you saw today will fall again. It's not a question of if, it's a question of when. And every time it does, someone, somewhere, will have to decide whether to adjust the ruler a little more, or accept that maybe we've been measuring with the wrong ruler from the very beginning. If this changed something in the way you look at the night sky, the like button exists for exactly that. And if you want to keep descending, because this wasn't even the most disturbing thing Webb has found out there, subscribing means you'll be here when I tell you the rest, because the next video goes somewhere darker.